to the kurtz ersa booth here at IPC Apex. Delighted to be joined by the President and CEO of kurtz ersa North America, Albrecht Beck. Welcome, Albrecht.
Welcome. Good morning.
Thank you. So we have a number of new innovations to have a look at on the booth today. You've been very, very busy in your innovation labs, which has been reflected with a number of awards you've won this week. So let's start with the selective soldering system beside us. Can you go through some of the key new features that you've built into your Versaflow?
I mean, at that show, our motto is Festival of Innovations, and that's what I will introduce to you a little bit and to our colleagues who look at us. The Versaflow 4 is a new generation selective soldering machine based on the already modular platform Versaflow 3, which is a very successful, well-known selective platform. On the Versaflow 4 doesn't really replace the Versaflow 3. We also have new innovations going into the Versaflow 3. The Versaflow 4 has let's say, advantages on modularity and on change over time on software, new software platform, For example, the gantry system here on the solder pod, we have an X, Y, and Z driven gantry system where we can have two individual solder pods on it, which will move also individually in C and Y, It's a combination X, Y, Z plus an extra individual C and a Y movement, all in one platform. So this is the most flexible soldering module on the market,
Absolutely. So you can have both pots. You can have working in parallel, or you can have one set up as a mini wave and one set up as a spot wave.
Yes, or individual. Two different alloys, big nozzle, small nozzle in a mix on one individual board, and this configuration can be added 3 times to the machine. So we can have up to 6 solder pods moving individually on that machine, and this is really high throughput, high volume, but starting at low volume, for average applications, and the customer can later on plug and play, retrofit individual modules,
Yeah, that's quite exciting. So really, they can, as you say, they can start with 2 solder pots here, and then in the field you literally take the end piece off here and extend 2 extra modules from the end of the machine here.
Right, 2 extra modules, and it can be also other methods of soldering, For example, we can have a multi-dip module as well with a full nitrogen channel, tunnel, where the board goes into an entire controlled nitrogen atmosphere and get a multi-dip. And it can have 2 multi-dip in combination with mini-dip modules, several fluxer modules. We can have 2 fluxer modules, 4 individual preheating modules, which can be segmented, so totally 8 preheating sections. I mean, that machine has almost no limitation in terms of flexibility and throughput. And the good thing, it grows with the customer's demands, and it grows with the customer. So you don't need to change machine, you grow it.
It's very exciting. So we've got a few other things that we want to see on the booth. So can we take a walk across next to the robotic machine that you've got, which I think is for rework? Albrecht, now we're in front of the Roboplace. Yes. Right. This is the first SMT vendor that I've seen that's actually directly getting involved in robotics. So tell us a little bit about Roboplace. He looks a very agile guy.
Right. I mean, it looks very human, right? It's that guy has a 2/7 axis robots arms, And
so each robot, each arm has 7 different axes.
7 individual axes, for rotation, movement. So you can do not just placing components straight, you could get it into an angle. You can program the force, how you assemble it, and you have cameras in the arm, you have suction cups, different gripper. So there is high flexibility, And for us, I mean, we want to introduce that into the through-hole component placement. I mean, for high volume, let's say high volume production lines where we have manual insertion people in front, and this is the most economic way you can do that, and we see a big market and a good future for that. Robot integration is not only in the electronics, we do that also in other fields of our business units. So we open the design and R&D center just for automation, and that's part of it, to integrate such collaborating robots.
So basically he's doing odd form placement, which was previously done by humans. What sort of throughput does he have?
I mean, you see it a little bit behind. The throughput is based on the two arm which collaborating parallel, so the throughput is higher than a manual, a human operator would do it. It's up to the component, you cannot say like on an SMD placement machine so many seconds per component. Throughput is here not the key, only the throughput is much faster than human, and it's more precise, and it's and accurate, and 24/7, no breaks,
no holidays,
no complaints. So it's an add-on, and that's just the start. I mean, we will see how the market takes it. We see a high interest on it, definitely.
Okay, so that's your Roboplace. Let's take a walk across now to the Versaprint, because you've had some new developments on that.
Yeah, we have a new printer here where we integrated the 3D SPI into the printer. We had already a 2D inspection and a line scan camera, full 100% inspection. That's still on the market, but now the new innovation is 3D, because most of the customers are requiring, especially in the automotive, are requiring 3D SPI, and we have that in the same machine, so less footprint, easier program software. It's self-correcting in terms of triggering the stencil cleaning, for example, if you have variations, and it has a traceability connection, and whatever an SPI system does, it's included,
So it automatically corrects the stencil if it has to.
It does. It triggers stencil cleaning, for example. If you have smearing, if you have less height of paste, so the machine reacts as a closed loop feedback to the 3D data which we measure here.
Okay, great. So, and finally, we wanted to quickly mention developments on your reflow oven with this new sinus wave. Can you tell us a bit about that?
Right. On the reflow side, everybody talks about voidless, and this is a big issue, in our industry. So we had to come with a good solution, and we did it different. We don't use vacuum. We want to have more throughput. We want to have a more cost-efficient solution, less running costs than a vacuum oven. So we did it with the sinus wipes, So we put waves of vibrating, very long waves in different packages. So that way we can have cycle times below 10 seconds. We are running around the 6-second cycle time, and do this sinus wipes in the last reflow zone where the board stops, gets separated, clamped and stopped, and then we put those waves into the board, and we get up to 100% void free.
So the vibration takes out eliminates the voids, or 99% of them, but the vibration doesn't affect anything else on the board.
It has other positive effects. It aligns the component. Let's say if you have a placement offset, the component is centering by the vibration sweeps to exactly the pattern, So it corrects also placement issues, and those are the two key features, to get zero voids, and this is repeatable, reproducible, And so we program depending on the number of void reduction we want. We start from 6 to 10 seconds. We can do also more, if it's very complex boards, but we get 100% void free that way.
Great idea. So continued innovation here at Kurtz Ersa. Albrecht, I want to thank you for giving us a walk around the booth today. Thank you.
Thank you very much for showing up. Thanks.